Dear students, in continuation with the previous video, in this video lecture, I will discuss about how a given ODE equation can be solved in the Python. I will compare three methods and I will compare the accuracy of three methods in the Python. First, let us import the necessary libraries. Import numpy as np, import matplotlib.pyplot as plt, and a special library to solve ODE equation from scipy.integrate import solve underscore IVP instead of the problem. Shift enter. Now let me give initial condition as we have solved in the Excel. Okay, I have to give my T naught value equal to 0 and my H value, let me give 0.2 initially, let me assume, and then y naught equal to minus 2, and then my n, let me have 20 data point, therefore t final will be 20 multiplied by number of points. Okay, shift enter. So here 20 points I want, and multiplied by I want 20 points, and what if you want to find what is the final value of t, it is 20 multiplied by h, it is n multiplied by h. I can change the value here. Yeah, now shift enter, and again I want to solve for the range of t span equal to here I am going to use a new term here, np dot range starting value is 0, my final value is t underscore final, and my step size is h. Okay, shift enter. Now I'll just give the comparison of the np arrange and np linspace. I'll show you np dot range starting value 0, the n value 10 with a space of 1, that will throw the result of 0 1 2 3. You can observe here my starting value 0 and the final value will be this value minus 1, so ninth value it is 9, and with the step size of 1. If you give the same input here, np dot lin space starting value 0 comma 10 comma, here if I have to give number of steps 10. Space. Yeah, you can check it here. Here also the starting value 0, the final value is 10. Here it is not n minus 1, but number of data point is 10. Okay, you can count 1 2 3 4 5 6 7 8 9 10. That is the difference between the using np arrange and np linspace. Okay, now I'm going to use only np arrange. Once I have given the initial set of values, now let me in our problem statement, my true solution which we connect in the Excel, true solution is y of t minus e power minus 2t. For that I am going to define a function, define true solution. For that I want to give only the input. We have only time need to be given here, so time should be t. Okay, I'm going to give time that, and that should return minus 2 multiplied by np dot exponential of minus 2 multiplied by t. Okay, and shift enter. And once I define function, let me do it only for the true solution. Let me call the true function. So y true equal to I will call the function true underscore solution. I need to give t. Okay, so t span. I'm going to give this entire t span, and you can check what is the t span value also. What is the t span I'm going to give here. So for this value, I'm going to generate my y true solutions. 0, 0.2. It is nothing but as we have done it in the Excel. Starting from a 0 value, then by adjusting h value, I can change the value. So here I given h value is 0.2, so 0, 0.2, 0.4. Similar way of doing the problem here. Okay, and then I'll run the code. Yeah, solution true. Let me copy paste here. Spelling mistake. Yeah. Shift enter. Yeah, now you can I want to plot the graph here. PLT plot my t underscore span. It is in x-axis, and y-axis I want to have y underscore true, and I want to give color red. Okay, comma, and line style I want to give single dash. Let me give double dash, and marker we give star, and label true solution. Close the bracket. Let me run the file. I'm getting the plot here, and now let me give one by one. Plot x label. I want to name it as a time, and plt while label it is y value, and I want to give let me run the file here, double quote, and I have given the labels for x and y axis. Now plt dot legend, running again. So legend have been given. Now I want to give the grid, plt dot grid. Shift enter. Again you'll get the grids, and again I want to give title comparison of ODE solutions. ODE solutions. Okay, shift enter, and plt shift enter. Yeah, you get a plot here. And now once I have found the true solution, let me now apply the Euler's method. Now Euler's method, I need to define again a function. I will define it in another line after defining the true solution function. Def ODE, I want to give time and y. generally you have to give time and y. In our case only the time value, and return I need to return what? I need to return minus 2 multiplied by y. So minus 2 multiplied by y. Okay, shift enter. Now I'll write the Euler's method as we have done it here. First you have to find this value. I need to add this value plus h multiplied by the previous value. For that I will initialize my entire cell as 0. What I'm going to do is I'm going to initialize entire value as 0. This as a 0. Sorry, yeah. This as a 0. Sorry. This value 0. This value is 0. And I'll do. So the same way we have the code here in the Python. So y underscore Euler equal to np dot zeros of length. How many cell value I'm having? Length of the time. So length of t underscore span. Okay, and I'll run the code again, and just I'll show you what is the code means. Now you can check what is the u. So you can run it again. So it will throw the array of with the 0 in each element. And what is this value? Length of t underscore span. That will throw the values of 20. That is the n. Okay. So now I define this. Once I define 0, then I'll create a for loop. Then we know that y of 0 now. Y of the same thing. I'll just copy paste that. Copy and Control V equal to. We know that the first value is minus 2. So that is nothing but first value. It is in the Python. The index first value is 0. That is nothing but my y0. So just I'll copy this y0 here. Okay, and again now I'll write for loop. Okay, what is the for loop? Once we determine this value, we extended this. We copied that formula for the entire columns. Okay, entire rows. So for that, similarly, we can use the for loop in the Python for that I in range. I'll just run a small for loop code. Okay, for I in range n. What is the n? Here in the case 20. So print I. You can check it here. That loop repeats. Start from 0. So the starting value of I is 0, and it is not n value. You not consider n value as 20 till 90. So it repeated that command for n minus 1 till n minus 1 times. Okay, so start from 0 to 19. It repeat 20 times, but the final value will be the n minus 1. Okay, so same thing I'm going to do it here. Now I want to do let me write the command code. Length of t span. What I have done, y of I plus 1. As we know that is equal to y of I plus h multiplied by I need to call this ODE again. Okay, I need to call this ODE. So ODE, I need to give what I have to give. So as per the formula, what we have is xn comma yn. So what is the here? T of I comma y this things. Okay, this, let me copy this value, copy here. Here it's not T of I, it is a T span of I, and y of Euler, the ith value. Okay, and I hope everything's fine. Okay, t span, yeah, I have to here, yeah, I need to have another one, yeah. So I can let me delete this code. Y is not defined. Okay, yeah, here there should be y Euler. Here also is a y Euler. Now let me run the code again. Yeah, here I have to -1 because it will take 20. I don't want to go till 20. Now it is running. Now let me plot the graph again. Euler's method. So here y Euler. Let me give blue color and line's tail. Let me give a single dash and let me give marker as V, and this is the Euler's method. Euler method. Shift enter. Yeah, so we have Euler's method, and you can observe here the true solution Euler's method have a distance. Okay, it is a error. Now let me solve the same problem by solve underscore IVP, that is uses the Rangan-Kutta 45 method. Okay, here let me create another line here. SOL equal to solve underscore IVP initial value problem. I have to give the ODE function. Then have to, what is my starting value of my integration, that is the t underscore t underscore 0 and t underscore final. So same thing what we have it here, t final. Okay, and I'm just giving the values of starting and end value. Then I have to give y underscore naught, my initial value, and then I have to give the value for which I have to evaluate. Okay, for this value I want to evaluate. For that I have to give t underscore EVAL equal to t underscore span. Okay, and to close the bracket, let me run the code. So let me give within the list. Yeah, now run. Now the solution contain that is, if you go to call SOL, you have these are the answers, but I want to only extract this. Okay, to extract that only that solution, I have to give y 0. So I extracted only the solution here. For that, let me go back here. I have to plot that. Copy this one. And here I have to take this value in the y-axis, and color, let me give black, and line style, let me give double dash, and the marker, let me give O, and it is a solve underscore IV function initial value problem, IVP within a bracket RK45. Okay, let me run it again. Let me check. Yeah, now we can observe that almost my RK45, that is the solve IVP, and my true solution merges. And now what you can do is you can reduce the H value, and you can give my 0.1, and again run all cells, and you can observe that the line goes closer. And again I can change the value of H here. Again, let me come back here, H value is 0.1, and again run all cells. Again you can check all the lines are merged here, but thing is it becomes straight line because my final value is decreased because so now you can check here n multiplied by h is very low value, only 0.2. For that I can increase number of data point, then give 200 and run all cells, and you can check the all three curves are merged together, and I can give the minimum values here. Let me give here even 100. Like that you can keep on change the values, and you can check what is the advantage of h value over the accuracy in all cells, and you can check the plot. Yeah, thank you for watching the video. Thank you.